The exponential quiz that was assigned last week. It will be due tomorrow, April 23rd. So what we're starting off here is exponential graphing. So you have this function here, f of x equals 2 to the x power. When we set up our table, we need to go ahead and at least make sure that we carry one negative value in there with us. So let's go ahead and do a -1, a 0, a 1, and a 2. And so when we actually plug this in to this function for f of -1, when we replace -1 with x, we will replace it with x here. Now again, please remember that negative exponents means that we take this base right here and we flip it. So we have 1 over 2 to the positive 1 power, which is the same as 1/2. So here we have 1/2. Okay? For f of 0, we replace the x with 0, and we have anything to the 0 power is 1. When we replace x with 1, we have 2 to the first, which is 2. And then when we replace 2 with x here, we have 4. So now, the only thing we do here is we go ahead and graph it. So we have -1, and the f of x is 1/2. We have 0 and 1. We have 1 and 2. We have 2 and 4. And so because it's an exponential, it's going to have a curve like this. Okay? So that's going to be number 1. Number 2, same thing. We're going to go ahead and set up our table. Now, the way we have kind of done this before in the past is we went ahead and we've kind of set it up where we treat the base to the power. So again, let's do the -1, 0, 1, and 2. Okay, so let's kind of just add another column here that just states that we're going to go ahead and multiply it by 4 after we take this and apply our x's. So let's do that. So we have f of -1, and we're just looking at our base with the power. So we have 1 over 2 to the -1. Again, this says we flip it. Okay, so now we're going to have 2 to the positive 1 power, which is just 2. Okay, when we replace 0, we have 0. We get 1/2 to the 0 power. Let's just make sure we do correct. Anything to the 0 power is 1. 1/2 to the first power is 1/2. 1/2 to the second power. So when we replace 2 with x, we have 1/2 squared. Okay, now again, remember, we are squaring both the numerator and the denominators. That's 1 squared over 2 squared, which equals 1 over 4. Now let's just go ahead and multiply everything by this 4 right here. So 4 times 2 is 8. 4 times 1 is 4. 4 times 1/2 is 4 over 2, which is really 2. And 4 times 1/4 is 4 over 4, which equals 1. So now we graph. We have the ordered pair -1, 8. So -1, 8. We have 0, 4, 0, 4. We have 1, 2, 1, 2. And we have 2, 1, 2, 1. And again, now we have an exponentially decreasing curve We know that it's a decrease or decay because our base is between 0 and 1. It's a fraction, 1/2. Okay? All right, so let's look at this. Analyze each table and determine if it has a common difference or common ratio, then determine if the graph represents exponential growth, decay, or is linear. So here, just like in sequences that we talked about before, we see that we are doing what? What are we doing here? Looks like we are dividing by 2. But when we're looking for a ratio, that's asking what are we multiplying by. So if we are dividing by 2, we are really multiplying by 1 over 2. Remember that, because if I said to you, okay, well, what is 4 divided by 2? Well, that's going to be the same thing as saying 4 times 1 over 2. Okay? So this is dividing by 2, which means that we have an exponential decay because it's decreasing, and our common ratio is 1/2. Okay? So again, if we look here at this next one, of course we're increasing. So we've got to go ahead and figure out, am I multiplying something by 1.6 to get to 3.1? And then 4.6. So one of the ways we can rule out what we have here is we'll go ahead and open up our calculator. And so if we have an actual ratio, just like if we took our second term and divided it by our first term, well, we would see that this reduces to 1/2, which is what our ratio is. Okay, and we can do that with every single term. So let's see. So if we take 3.1 divided by 1.6 to look for my common ratio, I would have 3.1 divided by 1.6, and that would give me 1.93. Now, if I take any other term, let's say I take my fourth term, which is 6.1, if I divided it by my third term, 4.6, I should get 1.93. So let's check that. We're going to go 6.1 divided by 4.6. And that does not give me 1.93. So therefore we know that it does not have a common ratio. So therefore we need to look for a common difference. Okay? So a difference is something that we are adding or subtracting by as we go down the line. So let's take 3.1 minus 1.6, and that will give me 1.5. So that's telling me that if I add 1.5 to this right here, to 1.6, it gives me 3.1. Let's try it here. So if I take 6.1 minus 4.6, I in fact get 1.5 here. So this has a common difference of 1.5, and it is linear. Okay, it's a linear function. All right, so let's look at these right here. Okay, so what we're multiplying is we're multiplying our variables, matching our variables to our exponents and our coefficients. So this is the same thing as we're going to multiply our coefficients, 3 times 2, and we're going to multiply our variables. We have x squared times x to the fifth. Well, again, we know that 3 times 2 is 6. And there's a rule here that says if I have x to the m power times x to the n power, then that's x, and I add my exponents if I have the same bases. So here, because I have the same bases, which is x, I will take this, and this will be x to the 2 plus 5, which will finally give me 6x to the 7th. Okay? Alright, so the next rule says that we have x to the m, this is a power to power, raised to the n. The rule tells me that if I have the base to a power raised to another power, I will multiply my powers. So in this case, x to the 3 times, or x to the third raised to the 6 is x to the 18th. Okay? Again, looking at this right here, because I have the same base, I can go back to the rule that I used right here, and I will add my exponents, x to the 5 plus negative 7. 5 plus negative 7 is equal to negative 2. Okay, now again, remember, because I have this negative exponent right here, I have to simplify it by taking the reciprocal of the base. The reciprocal of x is 1 over x, and I will make my exponent positive. Okay? So, this we're going to treat separately as well. We're going to take our coefficients, which we have 10 over 2, and we're going to multiply that by x to the fifth over x to the third. So again, we all know that 10 divided by 2 is 5. And there's a rule here that states if I have x to the m over x to the n, then that's the same thing as x to the m minus n. It's kind of the opposite here. You see, we had same bases here. Okay, we have a rule here that says x to the m times x to the n is the same as x to the m plus n. Well, in this case, we're doing the same thing, but we're subtracting them because we have the same bases, but we're dividing. So then we're going to have x to the 5 minus 3, which is going to give me 5x squared. Okay? So look at this last one here, or this next one here, 8. Okay? This is saying that we have this whole thing is cubed, but it's really saying that I'm cubing my x squared, I'm cubing my y cubed. So I can rewrite this in a different way by just saying x squared raised to the third power times y cubed raised to the third power. And again, our rule before with power to power is x squared to the third power is x to the 6th times y third to the third power is y to the 9th. So that's our answer. X to the 6th, y to the 9th. So this is just simply evaluating our function when our x is a different value. So we have f of 2 is the same thing as 3 times 2, replacing the x with 2, minus 5. So we get 6 minus 5, which equals 1. f of negative 3, again replace the x with negative 3 minus 5. So we get negative 9 minus 5, which equals negative 14. Alright. This is stating, well, if my g of x equals 5, what does x equal? Okay, so see the difference. Here we're replacing the x. Here we're replacing the g of x. So in this case, I'm going to have g of x is equal to 5. I'm going to push pause here 1 second.